All right, look at the QM assignment. I'll start with the last question and our review. So we are given the question to say, suppose 10% of new scooters require warranty within the first months of sale. The scooter manufacturing company sells 10,000 in its month. Calculate the mean standard deviation. Now, whenever you say a question like this, when you're given two things, number one, you're given P and you're given N, just know that this is what? Binomial normal. P here is what? 10%. Our N here is what? 1,000. Whenever your N is more than 100, it becomes a binomial normal. It becomes a binomial approximation of the normal, in short. So to start with, you can use your decimal. Our P is 0.10, meaning the Q should be what? 0.90. The two must add up to 100. Are we together on this one, the relationship between P and Q?
Yes.
All right. Then there are some formulas you need to know that fall under this distribution. Number one, so it's about the formulas here. This question was very easy, only that you needed to know the formulas. Number one, under the binomial normal, the mean has this formula, which is found by NP. Okay, we denote this as a mu. Then we have the variance, which is found by NPQ. Okay, we have the standard deviation, which is found by the square root of what? Come in. The variance. Are we together so far? Is this clear?
Yes,
Well,
it is. It's okay.
So if this is clear, I'll go back to the formulas.
You're calling this the binomial what?
It's a binomial normal.
All right. Thank you.
Okay, so it's called the binomial normal. So firstly, are we clear with these formulas that we have? Now, I want you to participate. If N is 1,000 and our P is 10% or 0.10 and our Q is 0.90, can you help me find these things? What is my mu? NP?
100.
How did you find that? 1,000
100.
and speed.
Oh, 1,000.
So which is 100. Are we all agreeable?
Yes.
Who's behind? Okay, so if we found the mean or the expectation, can somebody help me find the variance? How do you find the variance? 1,000 times what?
The variance is found by multiplying n.
NPQ. All right. So what are we getting?
$90.
9. Correct. Then the variance is simply the square root of what? The standard deviation is the square root of the variance. So what's the square root of 90?
9.4868.
9.4868.
9.4868.
Okay, so far the formulas are leading us, eh? Is there anyone behind?
Thank you so much for this formula, because for me, I was using a longer route. This is way better
Way better, right?
to find the variance. Yes.
Okay.
Me, to be honest, I'm very
Collins,
Yes, sir.
out of curiosity, this formula, I've been trying to look through that QM Bible and another book that I downloaded. I can't seem to find this formula. Is there a particular book that you got it from?
Even if you're to Google under binomial normal online, what's the formula? It's a standard formula. It's a common formula. Okay.
Okay.
Yeah. Formula of.
All right. Okay. Thanks. Okay. No, like the other lady said, it's a very simple formula and it's easier to use. It's just that I wanted to know where it came from.
Okay. Yeah. It's so some of these things come with research, and but I remember this from my 20 how many years ago. Yeah. So even if you go to Google, formula for mean under binomial, it's a known one. NP, you can see, right? It's a known formula. It doesn't even require a particular book. Are you seeing it throughout? You can see it, right? Yeah.
Yeah, I've seen it. Okay. All right.
All right. Okay.
Okay, thanks.
All right. So here the key was about knowing which formulas to use. Basically, there was no mathematics there. Yeah. So Leah, are you still behind? I don't know whether I should repeat that again.
kind. I think the network thrown me out.
Okay. All right, but what I've beamed there, it's just about the formulas per se. Are you still behind? Can you hear me? Am I audible?
Yes.
You are. Okay. So what's the next question asking for?
So could we round it off, the 9.48 to 10, or we leave it like that?
No, that one.
Round it up rather.
No, this one, leave it as it is, that one. But then leave
Okay.
it as it is, yeah.
Sorry, Collins. I'm lost in the fact that this question, is it the C or it's just first an example? And then how did you guys come up with all this? Yes, I can follow through, you substituted or something, but I needed some explanation behind.
Okay, so we're following the question, which is asking in parts. Number one, find the mean. The mean is simply the mu, which we found as what? NP. Then find the standard deviation. Standard deviation is simply square root of NPQ. That's what we've done so far, the 2 marks.
And that's the answer, 9 point something.
Yes, 9.486, yes. So this is what we found. 9.486. That is our standard deviation. And the mean is 100. Can we move? Are we together? I don't know. It's just a formula that you need to understand that. Yeah. Then we go to what is called moment coefficient of skewness. Moment coefficient of skewness. Of skewness. This one is also about the formulas. It's simply found by us subtracting Q minus what? P divided by the variance. So our Q was what? 90%, 0.9. Our P was 10%, 0.1. And our variance was what? 90.
9.49, 9.486.
This is the variance, the standard deviation, but the variance.
Oh, okay.
All right. So this one, in fact, it was you're right, it's supposed to be the standard deviation.
Supposed to be the standard deviation.
So Q minus P over the standard deviation. So our standard deviation was 9 point what? So he just wanted you to know, to do a study. I think it's not even there in the QM Bible. Yeah, or in your notes. Since this was an assignment, you were supposed to find out. Standard deviation is what? 9.486. So it's just based on the answers you're finding step by step. So when you divide that one over that one, we're going to get 0.084. I repeat, the moment coefficient of skewness is simply Q minus P over standard deviation. Our Q is 0.9, our P is 0.10. We're given the proportion. And divided by our standard deviation, 9.486. This is called our moment coefficient of skewness. All right. Then finally, we're being asked to find the kurtosis. Whereas skewness looks at how your distribution is bending to the left or to the right. This is skewness. If it's skewed to the right. If your answer is negative, it's skewed to the left. Kurtosis, on the other hand, measures the height of your distribution. If it's above, okay, the height of the distribution in short. So our kurtosis, spelled by kurtosis, has its own formula as well. Based on the answers that we found, it is simply given by 1 minus 6pq over the variance. 1 minus 6pq over the variance. So in this case, we have what? Our P was 10%. Our Q was what? 90%. And the variance was what? 90.
90.
Yes. So what answer did you find?
0.46 over 90.
Okay. Which gave us the final answer of what?
0.0051.
0.051. Okay. So I've tried to explain what kurtosis really measures and what the formula here is all about. Others were using whether it's V is NPQ, it's the same thing. All right, then divide that, you get 0.0051. So this is how the kurtosis, the height. So any questions?
Yes, I would like to ask a question.
Mm-hmm.
The interpretation of the 0.084 that you found, you were drawing something you were saying, I don't know if I got you wrong to say if you get a positive answer, then it's positively skewed, and then it's negative. So in this case, meaning it's positively, right?
Okay, so although I teach this in research, I'll be taking in your GBS 700. For now, I don't want to explain in depth, but when I'm dealing with skewness, it's just talking about whether you're skewed to the left or to the right. If most people fail, the distribution is skewed to the left. It means the distribution chaffing inequity is heavier on the left side. You can also use males and females. If the females are on the right, males on the left, and the skewness is on the right, it means there are more males there. So skewness looks at which degree of biasness. Kurtosis, on the other hand, measures the height, all right? Of course, it has it has levels. If you get a positive, all right, it has its own special name. It's called a leptokurtosis. If it's at 0 normal, it's called the normal meso. Okay, those terms are not really per se, but basically what you need to understand is that distribution statistics have a measure. If you're talking about height, that is kurtosis. If you're talking about biasness, whether it's left or the right, it tells you whether that is what? The skewness to the left or to the right. I hope that is helpful enough.
Okay, thank you.
All right, any other questions? Any other questions? All right, so